So I would like students to ask questions as soon as possible. Otherwise, if you're not responding, then I'll pick up few questions and I'll discuss. Okay. So there are plenty of sheets I have given. One of them is ionic equilibrium sheet. So in this very last hour, what we should do, that normally ionic equilibrium questions are like, alpha. Usually they ask degree of dissociation and all this. But when you dilute, then alpha approach fails. So students usually do what? Mostly what they do, they have only one thing, that alpha is equals to under root of k by c. I hope that you're not doing it, because you're all toppers and this approach works only at one place and never it works never. So I have given a plenty of problems just to show you that this approach should not be used a lot of, you should not be using it always. So that is why I have given you a few problems. All these problems are conceptual problems. Do you have any doubt in this strong acid calculations? This is particularly anyone, if I like this question number 6. How much water should be added to 100 liter of HCl solution having pH is equals to 3? Have you attempted this problem? Please respond. Anyone? No. So Ved Prakash, okay, Ved Prakash is the only one who is responding. So please uncam. At least 1, 2, 3 students should be there who should respond.
Second question, I'm getting different answer.
Yeah, Ved Prakash, have you done this question number 6?
Yes, sir.
So calculation was easy. There's nothing much in calculation. What is your approach of solving this problem? Okay, how you solved it? Could you share, please?
Final H plus I found using that, and then from water contribution and those two equations.
Okay, those two equations you're using. So basically we are saying that you have done this, that HX is the acid which is breaking into H plus X minus, and water is also breaking and it is giving H plus OH negative ion. So HX must be giving something like, if the concentration is C, we will make this C and C, and H2O will give A. Definitely. What is A? That is contribution from water. So total H plus will become C plus A, and that will become also C plus A. So that is a simultaneous equilibrium problem, and you have to solve it like this. A plus C into A is equals to KW. So already you know C, and you will calculate K by solving this quadratic equation. Since in this case, A plus C is given, because how much water should be added in 100 liter solution, so the pH of the resulting solution is 6.9. So pH is equals to 6.9. Basically, you have done this. Please interrupt me if you have done something else. So that means H plus ion concentration is equals to how much? 10 raised to the power minus 6.9, which is 10 raised to the power minus 7 into 10 raised to the power 0.1. I've already given the value of 10 raised to the power 0.1, because you see log of 1.2589 is 0.1. So anti-log of 0.1 is equals to 1.2589. So 1.2589 into 10 to the power minus 7. All right. That is the final H plus ion concentration. This is A plus C. All right. Since we know the H plus ion concentration, we also know OH negative ion concentration. That is equal to what? 1 upon 1.2589 into 10 to the power minus 7. Sorry. 10 to the power minus 14 divided by this, and that is equal to A. So once we get the value of A, then what you are going to do? What is A? Oh, sorry. Once we got the value of A, we will then calculate the value of C, and this C will be nothing but whatever amount of acid we have taken. Whatever amount of acid was taken, how much water should be added to 100 liters HCl solution having pH 3. So that time pH was 3. pH 3 means what? H plus HCl concentration must be 10 to the power minus 3 m in 1 liter. And which means that in 100 liter, it must have been how much? 100 into 10 to the power minus 3. So that is equals to 0.1 mole in 100 liters. So we come to know that in 100 liters, that was this. How much water should be added? Let us see, we have added V liters. So we can say that total V divided by 0.1 mole. Since we know that that was present initially, that must be equal to C. All right, Ved, have you done this? Like any shortcut, any fast method?
Same.
Same. Okay.
Yes, sir.
So a piece of advice that we can make it much faster. Simply use charge balance. Okay. You should be clear about the process, but you can also use the charge balance. Total H plus concentration must be equal to total OH negative concentration plus total, say, Cl negative concentration. Since this was given, H plus concentration was given, what was 1.22589? It was 1.2589 into 10 to the power minus 7. That is 10 to the power minus 14 divided by 1.2589 into 10 to the power minus 7. That must be equal to, let us suppose that Cl negative concentration is equals to 10 to the power minus 3 moles have been clearly seen. Okay? Because 1 liter was there, 100 liter was there, and 10 pH was 10 to the power minus 3. So 10 to the power minus 3 moles per liter into 100 liter, which is equals to 10 to the power minus 1 mole. Sorry. So this is 10 to the power minus 1. And this divided by V. We can simply use this expression to get the answer. Okay. So that is why I asked this question. Try to approach this by this method. That will make your problem much faster. However, this is going to give you the feel what actually is happening in this problem. Any doubts here? No. So another problem I have given, mixed acid problem. Question number 3. I hope that you also done this. Or maybe question number 4. Have you done this? What is the fund of this problem? What is is there anything, why examiner is so much interested in this? If somebody is going to ask you, what is the intuition of this problem? We should discuss, because normal routine questions you have already done. Why somebody is going to ask you some good question in the ionic equilibrium? So that must be focusing on some idea. What is the idea of this problem? Can you share?
You can just add those all C1, all equilibrium equations will get H plus square.
Oh, I'm so sorry. There is some mistake. Oh, I'm so sorry. Sorry. There is a printing mistake. This question was very interesting, but it has been destroyed. It must be 10 to the power minus 12. So sorry. All these questions are original questions, so I try to create them for surprising. So this question is, was this? Okay. So I'm going to solve this.
Even in this case, we can add those 4 equilibrium equations, we'll directly get H plus square.
Yeah, you're absolutely right. But this question is so special because, in ionic equilibrium, if you ask me what is a weak acid, so I will say the weak acid is that acid whose K ranges from 10 to the power minus 2 to 10 to the power minus 12. Why I say this? Why I say this? Because if K is less than 10 to the power minus 12, it is signed like 10 to the power minus 13, by 10 to the power minus 16, it may be possible. If K is 10 to the power minus 18, what is going to happen? If K is, say, approximately 10 to the power minus 18, examiner is not going to ask this question. Why he is not going to ask? Because then that acid will become such a weak acid that you could not count the H plus ion, because water is already a weak acid. It is weaker than water. So these kind of questions could not be asked. Clear, Ved?
Yes.
So have you ever seen any ionic equilibrium problem in which K is 10 to the power 18? No, you will not see. By the way, tell me, because don't think that I am interviewing you, because you are the only way in which I am making this class interacting. Thanks for that. Can you tell me the K of water? Can you tell me K of water?
10 power minus 14.
No, beta. This is 1.8 into 10 to the power minus 16. This is K of water. This is KW. What is the difference between KW of water and K of water? I tell you. By K of water, you could not calculate delta G naught. Delta G naught is minus RT ln KW. For this, you will always use, finding delta G naught, you will always use KW. Okay. But for comparing strength of acid with water, suppose I want to know which acid is stronger, CH3, COH or water. Then what I will be using? I will be using K of CH3, COH, and I will be using K of what? Water. So K of water is equal to, this is equal to KW upon concentration of water. Now, please, you can fight. You can say, no, sir, I don't agree with this. What you're doing, this is rubbish. Because H2O concentration I have never seen. Okay. So I'm telling you why we find K of water. We find K of water because we want to compare acidic strength. Suppose you are in organic chemistry. So what you will do? You have to find out the K of an acid. That will give you the tendency of losing H plus ion tendency. Okay. So here the idea is, now, how can I convince you? I'm a stranger. How can you just ask whatever I'm asking, why you should agree? You should not agree. Okay. So I give you another contention. What is KB of water? Can you tell me? What is KB of H2O? Anyway, this is same. This is KW upon water. Don't feel embarrassed. Okay. You all people, you all know it, but only I'm just putting my point of view. This is also KB of water. Very surprising. Why K and KB of water is same? Because water gives both H plus and OH negative ion. It gives both H plus and OH negative ion. So whatever is the strength of acidity, that is the same as the strength of basicity. So basically water is what? Both acid and base. So we have decided that the convention in chemistry, organic chemistry, chemists especially decided that we will give some K value to the water. And K of water then becomes what? K of H2O becomes what? This is KW upon concentration of water, which you know that 1000 upon 18. Now I'm going to ask you, if you know the K of this water, what is the KB of OH negative? Then we will apply the very famous principle, K of water into the conjugate basis KB. KB of OH negative should be equal to what? KW. So if you apply this, if you apply this, what you are going to get? KB of OH negative is equals to KW divided by KW and multiplied by 1000 upon 18. So this quantity will come 55.55. Now go and check any standard organic chemistry book, especially the international data. So what you will find? You will find that KB of OH negative is equals to 55.55. Similarly, you will find Ka of H3O plus is equals to 55.55. Strictly speaking, these values are comparison in aqueous medium. Chemistry is not only studied in aqueous medium, it also studied in HF, also studied in ammonia. There are a lot of chemistry, but your course is specially chemistry in which medium? Aqueous medium. Hence, I proved that the Bronsted and Lowry concept is a much bigger theory, but you have to study it only in water. And in water, these are some few typical values. If your curiosity is extending any further, you may ask me, sir, what about the K in alcohol? Will it be same? No, it will different. So, sir, can I get K value of acetic acid in alcohol? You can, but then you have to search for handbook of chemistry, international data, maybe some lab will give access to you, then only you will get it. So do you think ITJ is going to ask you? No. So now we are very confirmed that in ITJ syllabus, we know what is our arena, where we can play. And we are safely playing in this one. In organic chemistry, K is H3O plus is 55.55. Another phrase is there. These are theoretical questions. Any acid which is stronger than H3O plus will be considered 100% dissociated. No question about it. Any acid which is stronger than H3O plus is considered 100% dissociated. Okay. Can you name few acids? Yes, I will name it. HCl, HNO3, H2SO4, these are acids stronger than H3O plus. So we consider them 100% dissociated. Any base which is stronger than OH negative, any base which is stronger than OH negative, like any base, will be considered what? 100% dissociated in water. Clear? So I given you the context why I love this K of water, because I can quickly compare. Now coming on back to the physical chemistry ionic equilibrium. So if I give you acid, what kind of acids are there? Strong acid, weak acid, and weakest acid. People will not ask question about this. People will ask question about this and this. This will include what? HCl, HNO3, H2SO4, HI, HBr. When we talk about the weak acid, range will be approximately -2 to -12, maybe -13. So I tried to create a problem where I think ITJ will ask someday this question, and that will be theoretical kind of question very soon, maybe this year, maybe some other year. Okay, that if we take K is equal to 10 to the power -12, you should immediately be cautious that and C is equals to say 10 to the power -2, that H plus going to be very, very small. If H plus is going to be very small, then H plus coming from water can not be ignored. That is the idea. Whole idea behind this problem was this. Got it? Now I am going to take this problem with this correction and solve it. And I will do it your way, how you have done and why I have asked this question. So we have three acids, say HA, HB, and HC. And HA is breaking like this, A negative plus H plus. HB is breaking like this, B negative plus H plus. HC is breaking like this, C negative plus H plus. This is probably 0.1, 0.01, and 0.001. See the symmetry in the problem. This is 0.1, this is 0.01, this is 0.001. And this is K1 is equals to probably 10 to the power -13. That was 10 to the power -12. And that was 10 to the power -11. It was purposefully done. So we'll assume that this is -x, x and x, -y, y and y, -z, z and z. Total x, y, z, x plus y plus z, z plus y plus x. That will be the situation. And we have to solve another equilibrium we could add. Our intuition is telling us that we should add another equilibrium because these acids are very weak. So we should also add H2O breaking into H plus plus OH negative. This contribution also could not be ignored. I'm very sure. So here, let us suppose that A is coming from there. So that will become this. That will become this. That will become this. And this will become A plus X plus Y plus Z. So we have plenty of equations now. And we will see, interestingly, I've created problem like this, that 10 to the power -14 is equals to 10 to the power -13. Okay. Now see, we have to take some approximation, and very clearly you can see the approximation. This is going to be a perfect approximation. Beyond any doubt, this approximation is going to work. So we can find that we have three equations. 10 to the power -14 is equal to x into x plus y plus. I will write it simply h plus. Later on I will replace. Similarly, 10 to the power -14 is equals to y into total h plus at equilibrium. 10 to the power -14 is equals to z into 10 to the h plus, and kw is also 10 to the power -14. That is also a into h plus. Clearly, if we add all these things, 4 into 10 to the power -14 is equals to, we can see x plus y plus z plus a multiplied by h plus. So h plus whole square is equals to 2 into 10 to the power -14. Sorry, 4 into 10 to the power -14. So h plus is equals to 2 into 10 to the power -14. Now, very interestingly, you will find that x by y is equals to same. So x is equals to y is equals to z is equals to a. So what is so special about this problem? See, the degree of dissociation of all three assets is different. And our intuition is telling the degree of dissociation of which asset should be greatest? The asset with the greater K and lesser concentration. Okay, so that was the idea of the problem. Got it? What do you think? Sometime they can ask it. Yes, why not? Such a simple question. Approach was this. I'm sorry for this. See, this little that has killed the problem. Third problem is also like this. Third and fourth both are something like this. Now in this table, I have selected few very important questions like G. What will be your approach of solving G? Thought process. In quick second, I have to answer this. G.
Alpha approx to 1.
Very good. And if I ask you alpha approximately 1, how do you get this feeling that alpha is 1?
Using that K equation.
Because K is very large. Alpha is 1. Another thought is there. Yeah.
Using that K equation, we get alpha square by 1 minus alpha equals to 10 cubed. So alpha needs to be very small.
Got it. So in this case, if alpha is very large, then you will take alpha is equals to 1. Have you verified that alpha is really equal to 1?
Yes, sir.
How you verified it?
I mean, finally, if I assume that I get 0.999, so it is matching my approximation.
Perfect. Good. Very good. And I think that I'm showing other students as well what you are saying, how to verify that. So I can quickly also solve this problem, that how to verify that alpha is nearly equal to 1. And one more thing is, when you see that HA is 10.7, immediately you should strike that in this case, water's contribution could not be ignored as well. So this is one special case where this weak acid will behave like a strong acid. And even if it behaves like a strong acid, concentration is so low that water's contribution could not be ignored. So that is also going to be one interesting question, one heck of an interesting question. Someday they will ask it and mostly students will ignore it. Okay. And you might also have noticed that in most of the cases, the questions I have given, you don't have to solve the quadratic equation. If you have solved it, even if when you solve the quadratic equation, every time you're getting very neat and clean answers. So is there any way you can pick that why these answers are coming, like how I created this problem? So every time I am giving you a problem, you are getting a very nice answer, and JEE will also do that. Calculation will not be a problem. Is there a way I am doing it? Because all these problems have been created. You might not be, you will feel very surprised that every time, apart from one or two questions, you're always getting very nice answers, root of 2, root of 3, root of 21, root of 16, something like this. Think about it, why we are getting this. So such a symmetrical thing it is that examiner can make a lot of questions and they'll keep on creating. This chapter is full of potential. Anyway, you just figure it out. Let's move ahead quickly because we don't have infinite time right now. This is also one such question. If you do it, you will get a very satisfying answer. And in this case also, you will find that alpha could not be ignored. So I've given these questions that if you do it, you'll get a feel of thing, what they can ask in acid-base equilibrium. This is another question which you are going to get very neat and clean answer, because I don't think there is any typing mistake. Sorry for this. One typing mistake was there. We'll make this go. Anyway, in all the simultaneous equilibrium problem. Now let us move ahead. I think this brainstorming I will take now. This one. Have you tried this problem? This is seems to be a very dangerous problem. Have you done it?
Didn't get answer.
Didn't get answer. I'll tell you the funda. What was your approach of solving the problem?
I first assumed that fluid to be ideal gas, but that didn't work.
Okay, that fluid to be the ideal gas. Okay. Yeah. So why to take that fluid to be ideal gas?
No other option.
Because there is
I found the amount of virus present in the solution by assuming two variables. Amount of nitrogen is one variable and amount of the virus is the other variable.
Who is speaking?
Siddharth.
Siddharth, yes.
Then I got the amount of virus, but after that, after it leaks out, I wasn't able to get what.
Okay. So this question is based on two parts. First is there's a fluid. So why as a way we will not take it as an ideal gas. We'll take it as a fluid because you see the volume of this fluid is given 100 ml. And I think density must be given. So this 100 ml means what? 173 grams. The vial was having 173 gram of mass. Okay. So in 173 gram, you see virus is 1% by mole in the vial of capacity 100 ml. Due to 1% by mole is vial is a virus. So 1% by mole, that means 99, 1 mole is there, then 99 mole is what? Nitrogen. So by using this idea, we can do one thing, that let the mole of virus is equals to A. So A into the molecular mass of virus is also given. So A into 150,000 plus B is the, say, moles of nitrogen is there into what? 28. And this B should be equal to what? 99A. B should be equal to what? 99A. And this value is given, that is equals to 173. So can we get the value of A? Yes. So we can find that how many moles of virus is there. The first part of the calculation will be, we'll find the mole of virus. Done? Can we do it? Yes. You are all very good students, so you'll do it. So I remove all the step and simply say that, let us assume that I get the mole of virus. All right. Once I get the moles of virus, you see what is happening. The vial is broken and this vial has been broken, spilled into the atmosphere. And in 1 year time, it keep on spreading in the atmosphere. 1 year time, it keep on spreading. And I think 1 year time is sufficient. And you will agree that it will uniformly spread in the atmosphere. And during that 1 year time, this virus was kept on, by some atmospheric condition and all this harsh condition, virus was deactivated. So virus is after all a protein. So protein is denatured, something like this. This is in figure of imagination. So the another line, it should be there. Assume only 0.01% of virus survived after 1 year. So whatever will be the number of moles of virus, whatever you have calculated into survived only this much, that means into 0.01 divided by 100. So the factor of 10 power 4 will be there. So if X is the number of moles of virus you have calculated into 10 to the power minus 4, that will be the final number of virus. And that is a spread in whole atmosphere. Got the idea? So this is the first part of the problem. This is the second part of the problem. And I think this is pretty ordinary. We can get it here. Only thing is when we see a big problem, we lose our cool. And when we lose our cool, then we do mistakes. So these two steps, do you agree they're very easy? Because you may say, sir, this is a difficult question. So these two steps, you do it quickly. Now, this question is based on what? Barometric formula. How will it strike to a student that it is based on barometric formula? There is no other way in which approach this problem. Because the virus is spread in the atmosphere. This is the earth. And virus is spread in the atmosphere. And we know that atmosphere can go up to infinity. But luckily, we have a force of gravity. So if we have a force of gravity, then that force of gravity also acts on the virus, on everything. And due to that, the concentration of virus will keep on decreasing in the upper atmosphere. It will be maximum in the lower reach of the atmosphere, and it will be minimum in the, and at some point of time, the virus is going to be zero. So we have to apply the barometric formula. So what is the barometric formula? Barometric formula is a fantastic equation. It says that P at the ground level P at any height h is equals to P at the
P
ground
naught into E power
to the
minus
power
mg by
mgh upon RT. Anyone, you want to say something? You know this formula?
yes.
Everyone know this? We have also done in physics. We can also write in this way. Number of particles at height h is equals to number of particles at zero height e to the power minus mgh by kt. In fact, this is the idea of Boltzmann. So why this question is there? This is the whole concept of Boltzmann. Supplies everywhere. So Boltzmann said that greater is the energy, lesser is the probability of finding the particle in that state. Got it? So this is the idea of the problem, that n at height h will be n naught e to the power minus mgh upon kt, or capital mgh upon rt. I think you're aware of this. And similarly, we can write it like density at height h is equals to density at 0 e to the power minus mgh upon kt. What is m? M is the mass of the particle, g is the acceleration due to gravity, h is the height, and rt. Okay. So now we have a variable. Should I remove this? This is the idea, another idea. Barometric formula is going to be the problem solving trick here. So how to solve it? What we need? We need simply at ground, at z is equals to 0, we find what? N naught. What is N naught? Number of virus per unit volume. We just have to find this. Our problem will be done. So how to get this? So we will assume that in any such differential height, this is say dh at any particular height h. Okay. What is the density? Density is equals to say rho. Okay. So density is equals to rho and area into say dh. We can write it like this. What is this? This is the total volume. This is the total mass which is going to be present over here. Okay. So if this is the total mass present over here, this is, we can say, is equals to how much? dm. All right. We can think about it, that suppose our virus is spread. Only thing is we don't have to see atmosphere. We have to see only focus on the virus. So we'll focus simply on the virus and we'll think about it, that virus is having some number density. Okay. So in way that we can say that number of virus at any height h must be equal to number of virus at the ground level e to the power minus mass of the virus into g into h upon kt. That should be the idea. So we will take what? Earth, and we will take a differential volume into this one, and this differential volume will be equal to what? Area of the earth surface into dh. This area of the earth surface into dh is going to give us what? The total volume. So in this total volume, if we multiply this by what? N at that particular height h, that is number of virus per unit volume, number of virus per unit volume. So this is going to give us what? This is going to give us dn. Let me write it very clearly, because otherwise, sorry, this writing and writing is, should not be taking it casually. This is our earth, and we have taken, the problem is simple, but seems very difficult initially. Okay. So this is the differential area. In this area, I'm not going to make another concentric shell here. We will find the volume is equals to dV. In this volume dV, we will multiply it n at that particular height h. That will give us a small n. What is small dn? This is the total number of virus in this particular concentric shell. Do you agree? So we are just here now. So this dn is equals to dv, which is a into dh into what? nh. nh and nh is equals to n naught e to the power minus mgh upon kt. And now we are going to integrate it from 0 to infinity. So if you integrate it, you are going to get n is equals to a you will take out and n naught you will take out, and thus integral of 0 to infinity e to the power minus mgh upon kt into dh. That is n. So n is equals to a into n naught. And now we have with a negative sign, what is there? This is, we've integrated this kt upon mg, and this is, you have to put the limit e to the power minus mgh upon kt. Limit should be 0
Sir,
to, yes.
sir, how is area constant, sir? Area should increase with height.
So we have taken into consideration now. This area is, okay, you are saying that this area should also change with,
Yes, sir. 4 pi h minus r whole.
4 pi r square h. Okay, then we'll do one thing. This 4 pi r square, and this is going to be the h. This r is going to be a very, very big number. We'll have to take this assumption. Okay, because our atmosphere is, from our discussion, it is clear that our atmosphere is not going to be the compared to this radius. This radius is not going to be too big. So this is going to be practically constant.
Our limits
sir.
are till infinity. No?
Yeah, of course it is
Okay.
infinity, but in practical limit, if you find it that infinity is not going to be more than 10 to 15 kilometers height, but the total r is quite big. But this idea is valid. Okay, this idea is valid. Otherwise, this integral is going to be very difficult integral, and ultimately you are going to get the same result. Okay.
Okay, sir.
Yeah. So we will take this area as to be a constant area. That's a very valid point. Very good challenge is there. And 0 to infinity, you just integrate it. So when you integrate it, what you are going to get? N is equals to minus a n naught and kt upon mg. And what is this integral? You are good at mathematics. You tell me. 0. If you put it 0, this is going to be 1. And you put it infinity, it's going to be 0. So this is going to be, negative sign is going to be taken care of. Okay. So that means this is a very simple case now. N is equals to total area into n naught into RT upon mg. That was the idea. So you will get the value of what? By solving it, you will get the value of n naught. So n naught will come out to be what? N naught will come out to be what? N you know na? Into mg upon kt into a. But most valid point you have raised here, very good point, that why I should have written in this problem that consider this radius of Earth is to be too big compared to what? Infinite height. Do agree with that? So that might have given you a lot of thinking. Okay. Done. So now it can be done. So once you get the value of n naught, what you need to do? What is n naught? It is the concentration of virus per unit volume. It is the concentration of virus per unit volume. The final step will be then. Suppose you got the value of n naught, and each breathing you are taking volume V. And suppose we are breathing it, say, Z time, what I should take X time. I already used X variable as a here. No. So let us assume that we are breathing X times. So X into V into this is going to be the number of virus which we are breathing in, and that should be equal to 1. That should be equal to 1 because at least one virus should come. So that means we'll get the value of x. X will be 1 upon this particular n naught into V. Okay. So I think a very nice challenge you have done. I think I should add this particular thing in this question, then it will become a more appropriate question. That assume that the radius of Earth is too big and the atmosphere will become very thin, which of course you can put in the data and you can virtually check. But by the way, if we are taking that as a variable, then calculation is going to be very difficult. Then probably this integral is going to be consume a lot of time, but ultimately we'll get the answer. Do you think who has challenged this? Siddharth? Somebody has challenged?
Me, sir.
Sai. So do you think
Yes.
that in that situation, I should be doing this integral, that kind of integral you have done?
Yes, sir. We have to apply by parts. It will take time.
Yeah, it will take time. Although these are standard integrals. In physical chemistry, these are very standard integrals. And, x to the power n, e to the power minus ax, e to the power minus ax, or x to the power. These integrals are, relative, what we call it, average velocity, relative velocity. In all these calculations, they always come in wave function calculation. So I'm sorry for this, that I should have added this line. I do agree that assume that the radius of Earth is, although I have given the radius of Earth, which is quite a large radius. And beta exponential function dies very quickly. Where height is increasing, exponential function dies very quickly. So this mathematical acumen should be applied here. So do you think that that's a very difficult question? Yeah, it seems to be. You will get the answer, but very nice answer it is. This problem has been created keeping in mind coronavirus. So I searched in internet and I found that the coronavirus is nearly 138,000 grams per mole is the molecular mass of coronavirus. So I made it 1,50,000 to make calculation simple, and I have done as much as possible to make the calculation simple. And while I has recreated, of course you preserve any virus in nitrogen, and that is liquefied nitrogen. So I tried to create this problem to be quite realistic, and you can feel like how relevant this problem is, that if a virus is spilled, there is no way of getting rid of it. It will ultimately come into our system. See, this one vial has been broken, and even after 1 year, after so much destruction, in 16 breaths, you are going to catch a virus. Okay. Done. Do you enjoy this problem? Anyone who have solved it? Now you can see it. So find the answer. We'll find. Enjoy. So the most important thing is you must enjoy the problem. And idea was very simple. What do you think? Idea was difficult? Ved?
No,
Yeah. Okay. Next question is this. Have you done it?
I got answers for first two part, remaining two parts were not matching.
Remaining two parts. Okay. So in remaining two part, 40% of water into the purifier is rejected every second. How soon after the start the concentration will decrease from 500 ppm to 300 ppm? Okay. See this in C part, the volume is varying. V is varying. And how it is varying? So V is equals to some initial volume was there. And every second, what volume is entering into this one? Suppose this small v volume is entering into this one. So if some time t is taken, at some time t, what volume has been rejected? It has been said that third, if 40% of water entering into the purifier is rejected every second, that means 0.4 into small v. This much water is rejected every time. So every second. So at any time t, what will be your volume? You started with Vt is equals to V naught minus 0.4 into V into T. This much volume will be rejected. So we have to use this somehow to get the solution. So have we done this? First
Yes,
part, yeah. Can you try this now?
I did same, sir, but my answer is different.
See solution.
Sir, did you send this paper in that group?
Yeah, I have sent this paper in the group.
Sir, can you resend it again because I have joined recently.
Okay, okay. I'll do it. See, I have solved this problem. If you can see this eta word is there for the efficiency. By this, which is removing the purifier is removing 40% of water entering the purifier is rejected every second. How soon from the start the concentration will decrease from 500 to 300 ppm? Have you done it like this?
Yes, sir.
Can you find any mistake here?
No, sir.
So the situation will be like this.
How did you remove that square term in below?
Square term is removed like this. You see, this is AT and this is A0. And this is VT and this is V0 square. So I will cross multiply AT by VT and this divided by A0 by V0. So that will become VT by V0 and this will become concentration because AT was what? The question has been set in such a manner that that become AT by VT. Agreed?
Yes, sir.
So, you know, first time if you create a problem, sometimes when students solve, then they find some mistake. Na? So I was very cautious. That is why, but I've checked it many times. So I've created this problem in such a manner that you get a very neat and clean answer. Okay. So that it gives you a feel of ITJ. If they're going to ask this question, then answer should be very simple. T is equals to 1000 seconds. All right. Now you can also go ahead. What is the concentration of rejected water in ppm? That is not a big deal to find. Because you know how much water is rejected and you know how much salt has been rejected. Every second, salt is coming out of it. So you know total amount of water rejected and you know total amount of salt rejected. So you calculate it and it is going to be 800 ppm. I have calculated it on rough, but I have not written in the printed solution. You see the check it out. All right, convinced? So idea is you have done a lot of questions, problem solving. I'm just giving you a few problems, you know, 20% odd problems, which comes as a surprise in JEE. And we think like, you know, some out of box thinking is there. So we are identifying then and every chapter, what else they can ask as a surprise, what they can ask. Okay. So this virus problem is related to the barometric formula. It's a very, very common problem in higher physical chemistry to find these things. But I'm very happy that you have made a very valid point that if R is very large, then it should be given prominently. It should be written that the radius of Earth is, though it is very obvious, but radius of Earth is very large as compared to thickness of the atmosphere. The next question. So we'll do all three parts. And that's more than sufficient. One question is more than sufficient. Some mathematical, I think in mathematics, you also solve a lot of such kind of problems. You set up differential equation, not a big deal. Only two types of problems I've taken in which volume is constant and volume is varying. That's it from my side for this year. And I think ITJ has never asked this question in chemistry, but if they will ask, they'll ask like this. Next is brainstorming mixed question. What about this question number 1? Have you tried?
Didn't try.
Yeah. Who else is speaking? Yash?
Yes, sir.
Yeah, you have tried?
Yes, sir.
Tell me a
I
question.
didn't receive any register.
But you're not audible.
Sir, I didn't receive any of these papers, sir. I recently joined the group. So,
Okay, okay. Okay, okay. Ved, you have tried?
No, sir.
Okay. So I think I should discuss the theory of this question. What is the idea behind this problem? You see that we have seen in real gases, we always see this Z versus P graph. Z versus P graph looks like this. But there are many things which we always kind of fishing. We never be very exact. In at least in most of the problems which you usually solve, we are not very exact. Because for exactness, we must know what is dz by dp. And dz by dp involves what? An expression of z in
B by RT.
We'll take about this. First of all, we want dz by dp. No, find the temperature at which the slope of z versus p curve has a maximum value for CO2. Okay, so we are talking about z versus p curve has a maximum. Find the temperature slope of z versus p graph now. So at least the slope will come. Okay,
Can we take it as B by RT?
b by rty. Yeah,
Because
I'm coming on that point. I'm just giving you the idea. The idea is that we have always talked about this, and students always study this formula also. Z is equals to 1 plus b minus a by rt into 1 by v plus 1 by v square plus this is called virial equation. But since the virial equation is always in z versus it seems to be it is a function of v and t, we always misses a point. So we are never exact about this thing. Why this? What is the behavior of z versus p? But this z versus p is a very interesting thing because it kept on decreasing. Then it reaches to a minimum value and then it started increasing. So our analysis is not complete till we get an expression of z and p. Do you agree? So that is something which is missing. Z versus p graph sheet is missing. So the problem is kept in mind. This problem I have given you. Just keeping in mind that have you ever inquired about this? Sometimes it could be very interesting to think about it, how to approach this problem. Should I give you more time or should I start discussing the theory of the real gases slightly so that you can tackle this problem? Anyone? Yes, Ved, have you tried?
This PDF I didn't do it.
You have not done it?
This PDF I didn't done yet.
Okay, you didn't get this PDF.
I didn't do it. I was doing ionics.
Okay,
Managed.
Okay, you have doing ionic. So I think should I give you time with some hints?
Sure, sir.
Sure. Okay. So first is this. So let me tell you some theory of this one so that you can tackle this problem. See very carefully this problem. Question number 3. So that you should not be wasting this time. See, this is taking place at constant pressure vessel. If it is a constant pressure vessel, then you very well know what is going to happen. When the reaction will proceed, the volume is going to change. And when the volume is going to change, the concentration is going to change because of 2 reasons. One is the natural decay, another is the change in volume. So the 3 questions has been kept in mind. And in higher chemical engineering, this is a very common thing, very, very common thing, because most of our reactors are designed operate at a constant pressure. So I thought, why not to give after 20-40 years of the JEE, they have now not asked it. Sometimes 1 or 2 problems I have put when I was in Bansal classes. So those problems are doing circles right now. So whatever you see, the first time I tried to create a problem here, you see many guesses are there. So that is also very much on the card. And also you can see there is a concept of limiting region because the initial moles of A and B are 3 and 4. Don't think that the problem is difficult. Only thing is different. It is slightly different. Okay. So this is basically belonging to the kinetics, but a very slight twist has been given. And you see that I have written a solution and it's going into this much. It has been done. There are many ways of writing the solution, but that will be the student's solution. So that is also not a big deal, not going to consume a lot of time, but very interesting problem this is also going to be. Okay. So question number 3, 4, and 5 is going to be very interesting problem. And I believe that answers will be very simple. I've also given answer key probably. So when you try it, you'll simply get in 3 to 5 minutes, you'll get the answer. You see this? Answers seems scary, but they are very. See, the 4th answer is very simple, 47 by 16. 5th answer is also, and B, 50 seconds. So question has been set in such a manner that calculation part is not very important, but they're interesting questions. So try this. This is a very painstakingly I created this these problems because you have already done a lot of problems. So I think that I start getting a feeling of boredom. So if I keep on doing same kind of problem, lot of time. So in advanced stages, what we used to do, 3 to 4, 5, 6, very good question, then routine questions, so that I come to know about all the formula, and I should know the upper limit of our thought process, where we stopped, and that limit should be challenged. 1 or 2, 3 questions, that is it. So that is what I am planning to do. So in real guesses, you try this. These 3, 4, 5 questions are there. They're also very interesting question. I'm not going to kill this. Question number 6 is also very interesting question. All questions which I have chosen is very interesting question. What is this? The idea of this question is just to motivate you. If you have not tried, all of you have not tried. Once again, you try it because I've already put on this one. You see, if I take a container and if I leave this container open, the water will quickly rush out. This is called evaporation. So when water will rush out on unit area, when it will start rushing out, do you agree that rate of evaporation per unit area per unit time will be constant? Yes or no? Rate of evaporation per unit area per unit time. Do you have a gut
Yes, sir.
feeling? Will it be constant?
Yes, sir.
Yes. It will be constant. How do you know it is constant? Yes. बच्चों आप लोग परेशान तो नहीं हो रहे हो? Are you not getting
No, sir. No, sir.
परेशान तो नहीं हो रहे हो? ठीक है. देखो, sometimes ideas are very simple but they seems difficult. So what is the concept of vapor pressure? When vapor pressure establishes, then from unit area, if 100 molecules are going up, 100 molecules are going down. Do you agree?
Yes.
Then only vapor pressure establishes. So at the situation when the vapor pressure establishes, the rate of evaporation is equal to rate of condensation. Do you agree? This question is based on this funda. And since the rate of striking of the gas molecules on a unit area is given by this formula, dN by dt is equals to A into N into C by 4. Very nice derivation is there. That's a very important equation. Important because without this equation, you could not understand the rate of effusion and diffusion as well. Gaseous state. One student at your level should be very clear about this formula. So I made a problem out of this formula. So if gas molecules are there, their rate of striking on a unit area should always be constant, and it should only depend on temperature. Wow. This C average. This C average, and C average is equals to what? 8 kT upon pi m. These are all very nice derivations. We're not here to discuss about the derivation. These are standard results. So this question is based on this idea. Suppose you have exposed a liquid. After some time, the liquid will, evaporate. And if suppose 20 grams of liquid evaporated in 10 seconds, then you will precisely come to know how many liquid molecules are evaporating from a unit surface area per second. And if you get that data, how fast liquid is evaporating per second, then you apply common sense. That should also be for the vapor pressure, that should also be the rate of strike from the above. Am I clear? If you know the rate of evaporation, natural rate of evaporation of a liquid, you also come to know about what? Rate of condensation. And if you know the rate of condensation, then you can quickly find out what the vapor pressure. So this is the idea of the problem. What is the vapor pressure of water at temperature 300 Kelvin? Data is given dN by dt is equals to this. Given the rate of evaporation per unit area, okay, is equals to this 300, and N is the number of molecules per unit volume, and Ca is the average velocity of the gas molecule, and Dn is the number of molecules. Everything has been described. To use this data to find the vapor pressure of water. Very nice calculation will be there. Answer is very simple. Please try. Question number 7. Edge length of octahedral is this. What is the volume of cube of maximum edge length which can be scribed inside an octahedral? This question belongs to solid state. And I think that in solid state, you are very well aware of the fact there is an octahedron. You might have solved the problem of truncated octahedron. Do you? Just to motivate you, there's a cube. If you start cutting the cube like this, if you start cutting a cube along these corners, do you know what is going to happen? Anyone? So this cube is ultimately going to be converted into what? An octahedron. And all along this cutting, the symmetry of cube is similar to the octahedron in all respect. All the symmetries of cube will be there in the octahedron. And if you keep on cutting this octahedron along this, what you are going to get? Once again, you're going to get a cube. So I thought that you must know cube and octahedron are the basis of whole solid state. And mathematically speaking, they keep on alternating. You truncate a cube, you get an octahedron. You truncate an octahedron, you can get a cube. So this question is based on this fact. So can you tell me that, and they will make a very nice series also, that if the volume of this is V, this volume will be V times of, one fraction. Then once again, if you do it, next volume is also going to V times of another fraction. So this series is going to infinity series. That must be a GP series. A very interesting thing is there. So this is the basis of the whole solid state and symmetry thinking. So you try this problem just to motivate you. Very simple problem once again, if it strikes to you. If it don't strikes to you, don't waste a lot of time. I'll discuss the solution. But if you know this problem, you can read the brain of a person who is going to make a question on solid state. Because if you can start cutting the cube, you can also cut the tetrahedron, and you can come to know about it, the mathematical aspect of this. Anyone who has tried this problem? Question number 7. I think I have shared this. Answer is very simple. You see, 7th, to motivate you, I have set all this problem. 8. So it's going to be a very fun solving these problems. Take your time, 1 hour time or 2 hour time you should give, not more than that. Okay. So I hope that I have discussed all this. Answer key I have also given. Probably you have not tried this question because answer key has not been given. So I've shared the answer key as well. Try this and then come with, solving this problem. You may ask me, sir, physical chemistry is a very routine thing. Then don't ask me. Okay. You don't waste my time. Don't waste your time, because routine things you may ask me. I will give you 30 odd questions, and I am very sure that you have done all these questions. Every coaching institutions have taken all this problem, mixed them. They're going for 15, 20 years. The routine things you have already done. Have confidence on this. You have done the routine things. I'm only talking about some surprises. So what will be those surprises? We can pick it up. In every chapter, we can pick it up. See question number 10. This is also a very interesting question. This question number 10 is based on this fact. You might have seen this diagram. P0 A, Raoult's law, P0 B. Might have seen it, okay? You might have seen in this diagram, there is another diagram like this. This is XA is equals to 1.
Negative deviation.
Yeah. No, that's not negative deviation, beta. That's not negative deviation. This is ideal solution.
No, sir, the curve which is coming down.
No, that is not negative deviation. This is this is telling you the composition of vapor. And this is giving you the composition of liquid. This question belongs to the ideal solution. Find the number of moles of a vapor phase. Assume liquid A and B behaves ideally over whole range of composition. Raoult's law. Remember Raoult's law?
Yes, sir. Yes.
Yeah. This is a phase diagram. Why I'm calling this phase diagram? This is high pressure. This is low pressure. At low pressure, what is there? Gas. At high pressure, what is there? Liquid. This region belongs to what? Liquid vapor equilibrium. Recall. So this question is related to this. In this, you have solved many such questions, like we have taken a piston, and we have taken a liquid into this one. We applied P, very large. So this liquid is whole liquid. Now we started decrease the pressure. Slowly, a point will come when vapor will start forming. When you decrease it still further, one point will come. Only vapor will be there. So you have solved, I think, probably many questions related to that. That at what pressure vaporization will start, at what pressure vaporization will be complete, only vapor will remain. Okay. So these questions are related to fractional distillation as well. And we represent it like this. And I think I may recall you some formula. PT is equals to P naught A XA plus P naught B XB. This is how the graph looks like. The component graphs are, this is, if this is XA is equals to 1, this component graph is what? P, this is PA. XA into P naught. This is PB. XB into P naught B. And this is PT. That you know. That is Raoult's law. What I'm doing, you know already. Okay. So, but in this Raoult's law, this pressure is P naught A and this pressure is P naught B. What about this line? So we also know another formula. I think you are aware of that formula, that YA is equals to P naught A into XA divided by PT. Similarly, YB is equals to P naught A into P naught B into XB divided by PT. So you can eliminate YA and XA into this one, and you will get another very interesting formula. PT is equals to P naught A, P naught B divided by P naught A into YB plus P naught B into YA. Have you done it? You have done it. I think that you have done it. So by this graph, if you take and plot a graph of what? Simply YA is equals to 1 to YA is equals to 0, then you will get a graph like this. And you may ask, sir, why this graph is like this? Because this equation is hyperbolic, you know. So we have already done this. I'm discussing this. So if we have solved all these questions, then this question is very interesting. Since you don't interact, Ved, aapne kiya hai? Have you done it?
These questions?
These kind of questions you have done?
Yes, sir.
Yeah. So, do you have any doubt here? There's no time of going through the theory. But if I ask you one thing, What is the significance of this line? If I just make a line here, xa is equals to 1, xa is equals to 0, P naught A, say 200, P naught B is equals to say 100. And I make a line over here like this. So this line means what? You are decreasing pressure. This is high pressure and this is low pressure. So if you're decreasing pressure slowly, at this point, what is going to happen?
First liquid drop.
Very good. This is the point where the first trace of vapor will form. First drop of vapor will form. Do you agree?
Yes, sir.
So if the first drop of vapor is formed, and suppose this container was containing 10 mole of A and 10 mole of B. Okay, so mole fraction XA was equal to half and XB was equal to what? Half as well. So the first trace of vapor will form. So liquid's composition will not change because first trace of vapor means what? Liquid is in lot of amount. Vapor is very small. Okay, so in that situation, vapor's composition, liquid's composition will not change. What will be the composition of vapor? Definitely composition of vapor will be this. So this point gives us the idea of, should I call it YA, YB, YA? And what is this YA? Let us call this 1. 1 means what? First trace of vapor. YA1. And that time, XA is equals to what? XA1. Now you have decreased the pressure to this level. What will happen? A very interesting thing will happen. Let me paint it by 2 lines. So there are 2 things, one red and one blue. You know what is this red? This red is representing relative amount of liquid. Relative amount of liquid. And this blue is, amounting to what?
Is it reverse?
Amount of yes.
No, it is not reverse. Common sense. Use common sense.
Amount of gas.
See here what is happening. Mostly liquid is there. Where is the blue dot? 0. So this red is representing what? Relative amount of liquid. So you got it. Here liquid is getting lesser and lesser. And vapor is getting more and more. And at the last point, what is going to happen? You understand what I'm saying? This is the last point. Here, this red line become very small. So liquid is only very small, but vapor is too large. Okay. So this was the idea of this question. This was the idea of this question. So we are playing with this idea and this problem. Okay. And how to play with this idea? If you ask all other students who are finding it, sir, it is relative theory of we are studying special theory of relativity. No, this is very simple. Sorry, if you could not understand it, that's another point. Very simple. What is very simple? Suppose I have taken Z 10 moles of A and 10 moles of B. I will call it overall composition. Let's call this overall composition ZA. That means this ZA, capital ZA is equals to what? 10 by 20 is equals to half. So we say that in container ZA, overall composition will always be half. No doubt about that. Now it's a common sense thing that total A in liquid must be equal to total A in vapor. Or you can say, sorry, total A in liquid, total A must be equal to what? A in liquid plus A in vapor. Common sense. And this total A will be what? ZA into number of moles in liquid plus number of moles in gas. No doubt about that. ZA into N liquid plus N gas. This must be equal to number of moles of A in liquid. How much is this? It is related to XA. And since XA, denominator is what? Denominator of XA is equals to what? XA plus number of moles of A plus number of moles of B. Which state? Liquid state. So I should multiply it by N liquid. And similarly, plus XB should multiply it by N gas. Sorry. YB. YA into N gas. So you see, if you solve this equation, if you take N liquid common, so that is equal to ZA minus XA. That must be equal to N gas you take common, that is YA minus ZA. So we can say N liquid upon N gas must be equal to YA minus ZA divided by ZA minus XA. Such a neat and clean result it is. So now, this ZA here is equals to half. That is not going to change. That is not going to change. This N liquid and N gas is going to change. Another thing is, YA upon YB should be equal to P naught A upon P naught B into XA upon XB. In this particular case, P naught A and P naught B in most of the cases are given. Suppose P naught A is equals to 200. P naught B is equals to 100. So this quantity becomes 2 XA upon XB. And interestingly, we can also write 1 upon XA. That is equals to YA. And I can also write here 1 minus YA. Point is that we have two variables, XA and YA, and they're related. You already know what is ZA. If you know only XA, you also know YA. So these kind of problems are there. If you have taken total liquid is equals to N liquid plus N gas is equals to 20 in a container. So this problem is series of problem. This problem is based on such these two equations. That is it. I can create a lot of problem. I have told you the algorithm of problem. Now I can create a lot of problem. 10 moles of liquid, 20 moles of liquid is given. You are stretching it at some point of time. ZA you already know. XA, if you fix XA, you will get a value of YA. That is how I create this problem. That is the idea of this whole problem. And this is very interesting because it is related to fractional distillation, which is very important in chemical engineering. You're always interested in what? Fractional distillation, separating things out. That is the basis of this problem. Okay. It is related to the ideal gas situation. So related to what? Raoult's law. ideal situation. Once you perfect this, nobody can beat you. Then you can talk about, sir, what is azeotropic mixture. But first you complete this, then we can talk about the azeotropes. Why azeotropes are there? What are different things? I hope that you also done azeotropes as well. All the students have also done azeotropes, have been taught, done it. You got the feel of azeotrop? Yeah. You try this. This is also a very nice problem. Very good calculation is there. Then two special ionic equilibrium problems I have included here. If a buffer solution is diluted, feel it. 1 liter if you add, 2 liter if you add, nothing is going to happen. So I created a problem just to keep it in mind that just to change the pH, here you see 1 mole each of HA and NA is there. So pH is equals to 5. Just to change the pH from 5 to 6, how much water you need to add? You will be surprised to find this answer. Try this problem. How much water should be added so that the pHs can be changed? You can be made, okay? So question number 11 is there. And another problem I have added in ionic equilibrium. For what there was. Yes, that's another interesting question I've added here, 8. See, this is salt of weak acid, weak base, for which we always assume that alpha is same. We're also adding water into this one. So we are going to challenge in this case that wo hydrolysis ka jo formula hota hai, we are going to challenge this. Because everyone has mugged up that formula. pH is equals to half pKw plus pK minus pKb. In this problem, we are going to break that formula. Problem is very simple. 2-line solution is there. Okay, try this problem. It is also a very interesting problem. How much water should be added to 1 liter of 1m solution of A plus B negative to make the pH of solution 6? So these two ionic equilibrium problem, very nice, thought-provoking problem. And the first problem and this solid state problem I'll discuss in the next class. Now I don't have time. In Saturday class, I'm going to discuss everything about the cubic symmetry and octahedral symmetry, how to cut a cube, what happens, what are the different symmetry. That's a beautiful part of the solid state. And this is what is the unexplored thing in ITJ. Once they've asked about the truncated octahedron, but they are definitely going to ask it because that is the basis of higher solid state. So a problem on this and one problem we are going to do on this real gas. And believe me, by doing this one single problem, you will be champion of the whole real gas. As far as ITJ is concerned, as far as the Olympiads are concerned, we'll come to know everything about it after solving this problem. Sir, at minimum, what happens? What happens at this point? What happens at this point? What is why this goes up? And what is the Boyle's temperature? What is inversion temperature? So if you do this problem, probably we have a lot of other things we can pick it up. So I have chosen only one very, very intense problem in every chapter through which we can come to learn about everything. Okay. Don't waste time in calculations. Few questions are there, calculations. Whatever questions are there for calculation, I've written use calculator. Like that virus problem, you have to use calculator because the calculation is going to be big. All other problems, you don't require calculation. But in this question number 1, you also require calculation, A is equals to this, B is equals to this. So use calculator in this case in the last step. This also you should do because I could not get time to make this simple. And when I could also make it simple, no problem. A is equals to 20.885. I could make it simply 20. B is equals to 31.8. I can make it 30. So in these manners, I can make this problem look very simple. But I have chosen the real values. I have chosen all real characters here. That is why some calculation is there. Take to the last part and solve it. The second equation is Berthollet equation. See it carefully. Van der Waals equation is not the only equation. P is equals to RT upon V minus B minus A upon TV square. So that means in this case, this A is T dependent. A should be T dependent. But Van der Waals has done mistake. He has taken A is to be independent of temperature. That is why the Van der Waals equation is not very perfect equation. So the slight modification was done by the Berthollet. So I've taken one example of this Berthollet equation and given problem on this one. Okay. So I hope in Saturday, up to Saturday, you can do all these problems. So we'll discuss in Saturday. Okay. It requires only now. Yeah. Saturday को discuss करेंगे. ठीक है बच्चों?
Yes, sir. Sir, send this again.
Yeah, I'll send this on the group once again. I will resend it because keep on sending it on the group. That is already there. See this, the heading of this is mixed mind-blowing problem. Brainstorming questions mixed. Okay, bachcho. Take care. Bye-bye.